Ukraine is no longer fighting this war solely with tanks, artillery, and soldiers dug into trenches. A different kind of battlefield is emerging above the front line, behind Russian supply roads, across the Black Sea, and even in locations Moscow once considered untouchable. The weapon transforming that battlefield is small, inexpensive, and often nearly invisible until it is too late. A Russian vehicle does not need to reach a trench to become a target. A supply truck, a radar installation, a fuel depot, a group of infantry, or even a vehicle concealed beneath trees can now be spotted from the sky, monitored in real time, and struck before it realizes it has entered a kill zone. That is why Ukraine's drone war is becoming one of the most consequential stories in modern combat. Kyiv is not attempting to match Russia soldier for soldier. It is building a new method to find, track, and destroy targets using unmanned systems. Before going further, make sure to like, share, and subscribe to Military Force for more clear analysis on the weapons, battles, and geopolitical shocks defining today's war. So how did drones evolve from battlefield tools into the core of Ukraine's war strategy? And what does this mean for the future of modern warfare? Ukraine has moved drones from the periphery of the battlefield into the heart of its military strategy. These systems are no longer treated as minor support tools for specialized missions. They are becoming central to how Ukraine sees, strikes, defends, and reaches beyond the front line. In earlier conflicts, a drone was often viewed as an additional eye in the sky. In Ukraine, it has become part of the command structure itself. It can locate a Russian position, follow a vehicle, guide artillery, strike a trench, observe the outcome, and then help determine the next target. This shift matters because Ukraine is fighting a larger adversary. Russia has more manpower, greater artillery stocks, and deeper reserves of heavy equipment. If Kyiv tried to counter that only with tanks and infantry, the cost would be unsustainable. Ukraine cannot afford a war where every meter is paid for by sending large numbers of soldiers into exposed terrain. So it has pursued a different approach, one based on early detection, rapid decision-making, and precise attacks. Drones fit that model because they reduce the gap between spotting a target and hitting it. The creation of Ukraine's unmanned systems forces illustrates how serious this transformation has become. This is not simply a new unit equipped with a few quadcopters. It is a separate military branch built around unmanned systems operating in the air, on land, on the sea, and beneath the surface. UAVs can monitor Russian movements from above. UGVs can support dangerous ground missions where deploying soldiers would be too risky. Naval drones can strike or threaten Russian assets at sea. Underwater systems add another layer of pressure in areas where conventional forces are harder to deploy. That structure gives Ukraine something many armies are still working to develop: a direct link between technology, operators, intelligence, and battlefield action. A drone operator is not simply piloting a machine. He may be feeding live information into a broader kill chain. A small team watching a road can help artillery crews, FPV pilots, infantry units, and commanders understand what is moving toward them. In that sense, the drone becomes more than a weapon. It becomes a sensor, a scout, and sometimes the strike platform itself. This is especially significant on a battlefield where Russian assaults frequently rely on sustained pressure. Moscow can send infantry groups, armored vehicles, motorcycles, and light transports forward repeatedly. But each movement produces a signal. A vehicle leaves cover. A squad crosses open ground. A convoy uses the same road twice. Once Ukrainian reconnaissance identifies that pattern, the target can be tracked before it reaches the main defensive line. That is how an ordinary road can become a trap, and how a routine movement can result in a loss. The deeper point is that Ukraine is attempting to redefine the meaning of military power. Power is not only the number of tanks in storage or the number of soldiers available for an assault. It is also the ability to find the enemy first, share that information rapidly, and strike with the right weapon before the target disappears. This is where unmanned systems give Kyiv a practical answer to Russia's numerical advantage. They allow Ukraine to extend its firepower, protect its troops, and make Russian movement far more costly. For the United States and other Western militaries, this is a warning as much as a lesson. The war is demonstrating that future combat will depend on networks of sensors, trained operators, affordable strike systems, and swift command decisions. Armies that treat drones as secondary equipment may fall behind. Armies that integrate them into doctrine may control the tempo of battle. And once drone warfare becomes the foundation of strategy, the fight extends far beyond the trench line. Drones now appear in almost every mission Ukraine needs to fight, survive, and strike back. They are no longer used only to peer over enemy trenches or document attacks after they occur. They help construct the target map before the first shot is fired. A reconnaissance UAV can rise above a road, tree line, or ruined village and identify where Russian troops are moving. It can mark vehicles, track supply routes, and observe how a unit behaves before an attack begins. That information then reaches artillery crews, FPV pilots, mortar teams, and commanders who need a clear picture of the battlefield. This turns one small aircraft into the opening link of a much larger combat chain, and that chain is now shaping how Ukraine fights every single day. The strike role has also grown well beyond simple battlefield harassment. FPV drones can dive into tanks, armored vehicles, trucks, and clusters of infantry with a level of precision that older weapons often cannot match at comparable cost. Bomber drones can drop explosives into trenches, shelters, and buildings where soldiers seek cover after being spotted. In some cases, they allow Ukraine to attack a position without committing troops to the most hazardous part of the line. That matters because every trench assault carries enormous risk. A small drone dropping a grenade cannot replace infantry, but it can degrade a position, force movement, and make the final engagement less costly. This is why the drone is becoming both a weapon and a form of protection for Ukrainian soldiers. The mission set is not confined to the air above the front. Ground robotic systems are being used for tasks that would be dangerous for troops, including resupply, evacuation support, mine-related work, and movement near exposed positions. At sea, naval drones have shifted the balance in the Black Sea by compelling Russia to defend ships, ports, and coastal infrastructure in new ways. Underwater systems introduce yet another complication because they can threaten areas that are harder to monitor with conventional patrols. Together, these platforms demonstrate that unmanned warfare is not a single tool. It is a family of systems designed for different environments. From muddy trenches to open water, Ukraine is also pushing these systems deeper into Russia's support network. Medium-range and long-range drones can hit fuel depots, ammunition storage, radar sites, repair facilities, supply trucks, and transportation routes far behind the immediate fighting. This creates pressure in places that were once considered the rear, not the battlefield. A truck may be far from the trench, but if it carries shells or fuel, it still influences the next Russian assault. A radar may sit well behind the line, but if it helps guide air defense, it remains part of the fight. This is how drone warfare turns logistics into a target set rather than a background system. Domestic production is a primary reason Ukraine can continue expanding this model. Kyiv has worked to reduce dependence on foreign aid by building more systems at home and adapting them more quickly to battlefield requirements. Public figures suggest Ukraine produced more than 4 million drones in 2025 and has set a goal of more than 7 million in 2026. Ukrainian defense officials have also stated the country could reach up to 20 million drones per year if partner funding is sufficient. The number is significant, but the deeper value is agility. When operators identify a weakness, engineers can revise the design, test a new component, and return improved systems to the front. That short loop between combat experience and production is becoming one of Ukraine's most critical advantages. This is where quantity and adaptation begin reinforcing each other. A country does not only need many drones, it needs the right drones for the mission, the weather, the jamming environment, and the target. Ukraine's drone industry is learning from live combat every day, and that makes each new batch more closely matched to frontline needs. The battlefield is no longer waiting solely on slow weapons programs because small teams, local factories, and field operators can push changes at wartime speed. That pressure is now feeding into one of the most important developments in the drone war, the struggle against electronic warfare. Fiber optic drones are emerging as one of the clearest answers to the electronic warfare problem in Ukraine. For much of the conflict, both sides have deployed jammers to disrupt control signals, block video feeds, and force small drones to crash before reaching their targets. That created a continuous race between the drone pilot and the electronic warfare team. If the signal held, the drone could strike. If the signal was severed, the mission could fail within seconds. A standard FPV drone relies on radio communication between the operator and the aircraft. That link transmits control commands and live video so the pilot can steer the drone into a tank, trench, truck, or bunker. But on a battlefield saturated with jamming systems, that invisible link becomes a vulnerability. Once the enemy identifies the frequency, the drone may lose direction, its video may cut out, or it may drift away from the target. This is why electronic warfare became one of the most effective defensive layers against inexpensive attack drones. Fiber optic drones address that vulnerability in a very direct way. Instead of depending solely on radio waves, they carry a thin physical cable that remains connected to the operator as the drone flies forward. The concept may sound dated, but in this war it has proven extremely effective. If there is no conventional radio link to jam, the enemy has far fewer options to break the connection. The pilot can continue seeing the target, continue guiding the aircraft, and press the attack even inside a zone where most wireless drones would fail. This does not mean fiber optic drones are without limitations. The cable adds weight, restricts the drone's maneuverability, and can snag on trees, buildings, wires, or uneven terrain. The drone also requires careful handling because the line must unwind smoothly throughout the flight. But the advantage is significant. Some reports indicate these systems can reach beyond 30 kilometers while maintaining a stable video feed, giving the operator greater control in areas dense with jamming. In a war where a few seconds of clear video can determine whether a strike succeeds, that reliability is decisive. Russia was the first to deploy this method extensively in several sectors, particularly around Kursk, and that created a serious problem for Ukraine. Russian operators could push FPV drones into zones protected by electronic warfare and maintain control throughout. But Ukraine did what it has done repeatedly in this war. It studied the concept, refined it, and incorporated it into its own production system. By mid-2025, more than 80 Ukrainian-designed fiber optic systems had reportedly been approved for use, with numerous local companies participating in the effort to build or integrate them. The broader lesson is not that fiber optic drones will determine the war on their own. They will not. They are not decisive weapons, and they can still be defeated by nets, small arms, difficult terrain, operator error, or physical damage to the cable. But they illustrate how rapidly modern warfare is evolving. One side erects an electronic shield. The other side finds a path around it. Then the first side seeks a new countermeasure. The battlefield becomes a continuous contest between defense and adaptation. For Ukraine, this is especially critical because drones are now tied to survival, not only offense. If Russian jamming can neutralize Ukrainian FPV teams, then infantry positions, supply roads, and artillery crews face greater danger. If Ukraine can keep drones flying through that interference, it can continue hunting vehicles, disrupting assaults, and shielding its own soldiers from direct contact. That struggle over the signal is now becoming a struggle over movement itself. The drone war is now extending danger far behind the visible front line. In older battlefield thinking, the most lethal area was typically near trenches, artillery positions, and assault roads, where soldiers expected the heaviest fire. But Ukraine is redrawing that map. The danger zone is no longer only a strip of land between two armies. It can now extend across roads, rail junctions, fuel stops, repair yards, and staging areas that sit well behind Russian forward positions. A vehicle may be distant from the trench, but if a drone can see it, that vehicle is already inside the fight. This is why logistics has become one of the most critical target categories in the war. A Russian truck does not need to carry soldiers into a direct assault to matter. If it carries ammunition, fuel, food, spare parts, or engineering supplies, it helps sustain the offensive. When Ukraine strikes that truck, the damage does not end with one destroyed vehicle. Shells may arrive late, fuel may not reach armored units, infantry may wait longer for support. A local strike can slow a broader operation, and that is the real strategic value of attacking the rear. Ukraine's medium-range drones illustrate how deep this pressure can reach. Public reporting has described the Morok drone as a system designed to hit Russian logistics from roughly 20 to 300 kilometers behind the front, including targets along the R-280 Novorossiya highway. That road is significant because it connects Rostov-on-Don to Crimea through occupied southern Ukraine, supporting Russian movement along a lengthy military corridor. When a route like that comes under persistent drone threat, it stops functioning as a secure rear road and begins operating like an exposed battlefield artery. The effect is not only physical, it is also psychological and operational. Drivers may adjust their schedules. Convoys may fragment into smaller groups. Commanders may seek longer alternate routes, add escorts, or delay movement until weather or darkness provides concealment. But every adjustment carries a cost. A longer route consumes more fuel. A delayed shipment disrupts timing. A smaller convoy may be harder to spot but carries less cargo. This is how drones pressure an army without always needing to destroy everything they observe. The same pattern is visible across occupied territories. Ukraine's leadership has stated that Russian logistics are now vulnerable throughout occupied southern and eastern Ukraine, and recent strikes have focused not only on battlefield vehicles, but also on oil infrastructure, refineries, fuel depots, and transportation support. That matters because modern armies consume vast quantities of fuel and ammunition. If those supply flows become unreliable, tanks, artillery, air defense systems, and infantry assaults all feel the strain at varying levels. This is where the concept of a modern no man's land becomes relevant. In the First World War, no man's land was the lethal space between trenches. In Ukraine, the definition is broader and more fluid. It can be a road 50 kilometers from the front. It can be a fuel stop behind a tree line. It can be a bridge, a warehouse, or a vehicle part that soldiers believed was safely out of range. The sky transforms these places into exposed ground. For Russia, this raises a difficult question about movement. Large forces still require roads, fuel, repair facilities, and reliable supply chains. But if those routes are monitored from above, every trip becomes a tactical calculation. A commander must weigh whether the mission justifies the risk, whether the cargo can be delayed, and whether the road has already been mapped by Ukrainian operators. Once movement becomes hazardous behind the line, the battle is no longer only about holding territory. It becomes a contest over who can move, who must remain hidden, and who can keep the war machine running under constant observation. Modern warfare in Ukraine is shifting away from the old question of who has more troops and toward a sharper one. Who can see first, decide faster, and strike with better coordination? Russia still uses attrition as a tool. Its forces continue sending infantry, light vehicles, armored carriers, motorcycles, and small assault groups toward Ukrainian positions. The logic is straightforward. Keep pushing, keep probing, and force Ukraine to spend ammunition, drones, and manpower stopping each wave. But that approach has grown more costly because the front is no longer blind. A Russian assault group may attempt to advance through a tree line, cross a field, or use a back road to avoid the main route. From the ground, that movement can appear minor and difficult to follow. From above, it becomes a pattern. A Ukrainian UAV can observe where the group originated, where it is heading, and whether additional troops are following. Once that movement is confirmed, the assault is no longer just a localized attack. It becomes a target within a wider kill chain. Ukraine's advantage comes from compressing the time between detection and impact. A reconnaissance UAV locates the target. The operator relays the coordinates. An FPV team, mortar crew, artillery unit, or another strike asset receives the data. Then the attack is executed before the Russian group can fully disperse or reach cover. After the strike, another drone may remain overhead to assess damage, track survivors, or identify a follow-on wave. This process does not require a large armored engagement to be effective. It can break momentum at the level of a squad, a vehicle group, or a small supply movement. That is why surveillance has become as valuable as firepower. A weapon is only effective if it can strike the right target at the right moment. And Ukraine is working to forge that connection faster than Russia can adapt. If Russian forces move in larger formations, they become easier to detect. If they split into smaller teams, they may sacrifice coordination and mutual support. If they delay too long, the assault loses its timing advantage. Each option carries a penalty, and drones help Ukraine impose those choices repeatedly. The human element remains central. Drone warfare is not only about machines in the sky. It depends on operators who understand the terrain, read movement patterns, share information rapidly, and adapt under pressure. Ukraine has encouraged drone teams to develop and test new tactics from the field, giving small units greater flexibility to improvise. A pilot who discovers a more effective attack angle, a safer approach route, or a smarter way to track vehicles can translate that lesson into a battlefield method very quickly. This represents a meaningful contrast with a rigid command culture. In a fast-moving drone war, waiting for slow authorization can mean losing the target entirely. The side that learns faster may gain more than the side that simply attacks more frequently. That is the deeper transformation now visible in Ukraine. Modern combat is no longer purely a contest of mass. It is becoming a contest of vision, speed, data, and human judgment. And that is the question the conclusion must confront. If war is now determined by who sees first and learns faster, what becomes of armies still built primarily for scale? The drone war in Ukraine is becoming a warning for every modern military. Tanks, artillery, and infantry still matter, but they are no longer sufficient when the enemy can monitor roads, track small units, and strike support lines far behind the trenches. Ukraine is demonstrating that military power now hinges on speed, visibility, and adaptation. A reconnaissance UAV can expose movement. An FPV drone can turn a small target into a significant loss. A fiber-optic drone can keep flying through intense jamming. A ground robot or naval drone can extend the fight into areas where soldiers and ships face greater risk. For Russia, the pressure is not only about vehicles destroyed. The deeper threat is operational degradation. When supply routes are under attack, assaults lose rhythm. When fuel and ammunition arrive late, even a large force becomes harder to maneuver. This is the lesson for NATO, the United States, and every military studying this conflict. The future may belong to the side that sees first, learns faster, and integrates machines with human judgment. For more clear analysis on weapons, battles, and geopolitical shocks, subscribe to Military Force.